In this video, we're going to go through some task cards. Let's see what this first question is asking for. It wants me to find the limit as x approaches 3 from the left of h of x. So I'm going to go to the graph and approach the x value of 3 coming from the left-hand side. I see that the output approaches a limit of -1. The next question wants me to find the limit as x approaches 3 from the right-hand side. That's going to give me a limit of 0. Question 3. Well, this limit only exists if we have the same output approaching 3 from the left and the right. And we can see from the previous two questions that the left and the right-hand limit are not equal. That tells us our limit does not exist. When we're asked to find h of 3, we're going to input 3 to the function and see what the output on the graph is. So the output of the graph is 0, since there's a closed-in circle in the graph at 0. Question 5 says, the limit as x approaches a of h of x equals 1 for what values of a? So a is an input. So we're looking for x values, where if a was that x value, we would have the output of 1, or a limit approaching 1. So you can see right here, if x was equal to 1, our limit as x approaches 1 would be equal to 1. So one of our a values is 1. Also over here on the graph at 4, as x approaches 4, we also have a limit equal to 1. Let's go on to the second card. Okay, so a table gives us limited information about a function. So we're just estimating a limit. It's possible something else is happening on the function that we're not aware of from these selected values of the table, but we're just going to make our best estimate. So, it looks like, from what we can tell on our table here, these x values are getting very, very, very close to -1, approaching from the left. And as we find our limit as x approaches -1 from the left, it looks like these y values are approaching 0.25. Do we know for sure the limit from the left is 0.25? No, but we're just estimating. That's the best information we're given in the table. Coming the other direction in the table, let me change colors here. Looking at these x values, now moving up the table, we're approaching -1 from the right-hand side. And as we approach -1 from the right-hand side, these y values look like they're getting close to 0.25. We're just estimating. We're using the best information that's available to us. Okay, now we don't even need to look at the table for question 3. If our left and right-hand limits are both equal to the same output, our limit exists and it equals that same value. Now, what is the output from the table at -1? It's 0.25. Okay, let's look at the table at the bottom. Well, this 7/9, as x approaches 7/9, that 7/9 is actually the decimal value, 0.7 repeating. Actually, I could put an equal sign here. 7/9 is the same as 0.7 repeating. So these values in the table are approaching 7/9. So as we're approaching 7/9 from numbers smaller than it, that would be coming from the left, our y value is constant at -1. So it looks like our best estimate is that our y values are approaching -1. From the right-hand side, same thing is happening. As we approach 7/9 from the right-hand side, our y values are still approaching -1. So kind of what this graph might look like is we would have the input 7/9 on the graph. So it looks like our outputs are probably around -1, except at 7/9 the function's undefined. So even though the function's undefined, since we're approaching the same output from the left and the right, the limit exists and equals -1. And g of 7/9 would be undefined. The function does not exist there. Okay, next, we have a couple graphs, M and N. So we're finding the limit as x approaches 3 from the left of m of x. So that would be right here. It approaches an output of 0. We're next approaching 3 from the right of m of x. That approaches an output of 0 again. Since the graph approaches the same output from both the left and the right, our limit exists, and it would also equal 0. But does our function exist at 3? Our function doesn't exist there. There's a hole. So m of 3 is undefined. Okay, why don't you pause the video, do 5 through 8, and then hit resume to check your answers, and we'll talk about 9 and 10 together. So try 5 through 8, pause the video, and resume for 9 and 10. Okay, and 5, our left-hand limit as x approaches 3 is equal to 4. Our right-hand limit as x approaches 3 is equal to 1. Since the left and the right-hand limits are not equal, the limit does not exist. And then the output of the graph at 3 is equal to 4 since we have this dot on the graph here. Okay, last two are a little tricky. For what value of a does h of a plus 1 equal 0? Well, what number, when you add it to 1, gives you 0? Obviously, negative 1. So we need h of a to equal negative 1. So we need, when you input a to our function, we need the output to be negative 1. So that's going to be here and here on the graph. There's twice on the graph where our output is negative 1. That happens when a is 0.5, right here, and when a is 4. Those are the two values of a that would, if we were to first find h of a and add 1, we would get 0. For what values of a does h of a plus 1 equal 0? The plus 1 is inside the parentheses this time. So let's go ahead and let me change colors here. Okay, so I want the output to be 0. And that happens here, h of 1 equals 0. But this time I need a plus 1 to equal 0. So if a here was 0, 0 plus 1 would be 1, and then h of 1 is equal to 0. So for question 10, one of our answers for a is 0. Here on the graph, this input of 3.5 gives us an output of 0. So I need h of a plus 1 to equal 0. So in order to have this entire input be 3.5, a would be 2.5, or 5/2. Equivalent expressions are acceptable. Okay, let's take a look at what we have here. We have the graph of f, so we know a lot about f. We have limited information about g. G is the information given in this table here. Let's see what we can do. We want to find the limit as x approaches 1 of g of f of x. I'm going to go inside first and find the limit as x approaches 1 of f of x. I'm going to highlight that on the graph. The limit as x approaches 1 of f of x is negative 1. And then I'm going to find the limit as x approaches negative 1 of g of x. So now I go down to the table here, and I'm looking what is the limit as x approaches negative 1 of g of x. If I'm finding a limit, I don't care about what's happening at negative 1. I only care about what the function's approaching from the left and the right. Is the function approaching the same limit from the left and the right? Indeed, it's approaching a limit of 4. In that case, our limit exists and equals 4. Okay, number 2. Limit as x approaches 1 of f of g of x. So I'm going to go first and find the limit as x approaches 1 of g of x. So we're looking at an input of 1 that looks like it's right here. Limit as x approaches 1 of g of x. Again, when I'm finding a limit, I don't care about what's happening at the point. I just care about what's happening approaching. So approaching from the left and the right, I see that the limit equals 3. So then I'm going to take that 3 and find the limit as x approaches 3 of f of x. Okay, that limit as x approaches 3 of f of x. So let's go to our graph and find the limit as x approaches 3. So we're finding the limit from the left and the right, and that limit is going to equal 0. Number 3, the limit as x approaches 0 of g of f of x. So actually, we've done 2 of these together. I'm going to pause the video, let you try example 3, and then we'll do 4 and 5 together. So go and pause the video and try example 3. And for example 3, I got an answer of 3. Number 4, I'm not finding a limit this time. I just need f of g of 1. So I'm not looking for the words limit. I'm just finding f of g of 1. So let's find g of 1 from the table. G of 1 is 2. Now we're going to find f of 2. So going up to the graph, f of 2, that looks like it's undefined. I don't see any value on the graph at 2, so this is going to give me a final answer of undefined. Number 5, the limit as x approaches 2a of f of x equals negative 2. So let's look at the graph and see where our function equals a limit or has a limit equal to negative 2. That would be right here. That would be the limit as x approaches 5 of f of x would equal negative 2. So if I need this to be my statement for my limit, that means I need 2a to equal 5. So if 2a equals 5, a would equal 2.5 or a would equal 5 halves. Equivalent expressions are acceptable. Either one's fine. Okay, really important. Let's talk about these true or false statements. True or false? The limit as x approaches 2 of h of x can be 7, even if h of 2 is 1. Think about that. Can our function have a value elsewhere and have a different limit? It sure can. So on the graph of h of x, our graph can have a limit of 7 as long as the graph approaches an output of 7 from the left and the right. And we can have the function value elsewhere. H of 2 can be down here at 1, and our limit can equal 7. So that definitely is true. Last one, true or false? Our limit as x approaches 2 of h of x can be 7, even if the left-hand limit is equal to 1. No, that one's false. In order for the limit to exist, the left and the right-hand limits would both have to equal 7. So as written, statement 7 is false. Thank you very much.